Okay, day 7, trig functions and transformations. Given the graph, write the sine and cosine functions. Alright, so... Okay, so for our sine function, what we have here, we have pi over 4 and negative 5. And then we have 9 pi over 4 and then 1. Then you have negative 7 pi over 4 and 1. So what we can see here is that the period, the distance between this point and this point, between two cycles, is 16 pi over 4, which is 4 pi. And that is double the normal, the parent function, which is 2 pi. So let's first write the sine function. So this would be f of x is equal to so let's just write out the variables. So a sine of bx. I don't remember if these are the exact variables, but I'm just gonna write how I remember it. So like this. So as you can see here, if we look at the period, it's 4 pi, which is double the normal. So we know that this b right here has to be a 1/2 x. And then our minus h, as we can see here, normally this would be right here, so we just have to see this distance, and this distance appears to be about 5 pi, and not 5 pi over 4 that it seems to have moved. So we can replace the h with minus 5 pi over 4. Alright, and then if we look at the amplitude, we can see the total distance from top to bottom is not negative 6, is 6. So now the amplitude has to be 3, and normally the amplitude is 1. So we know that this has to be 3, like this. Then lastly, our k. That means that if this were to be a normal function, that means it would look something like this. It would look something like this. Let me draw this better. It would look like that. So we know in that case that means that it has been, it's been shifted down. It looks like 2 units. Yeah, it looks like it's been shifted down. Oh wait, no. Let's see. No, because it would be like this. Or yeah, it would have looked something like this. Yeah, it would have looked something like this. So, and that means that this point right here would have been right here. So that means that this would be I mean that this is a shift down of 2. So this is our sine function. Now let's just erase all of this. Alright, for our cosine function. So for our cosine function, a lot of it's going to stay largely the same, because the period and the amplitude on the parent sine function versus the parent cosine function is going to be the same. So we know that this still has to be 3 cosine, and then this is still going to be 1/2 x. but our differences come in the h and the k. So a parent cosine function would look it would look something like this. It would look something like that. Yeah, so basically what we have here, we have it appears to have been shifted. What would be here has been shifted down to there. So basically what it appears to be is that it is shifted to the left. Shifted to the left by, it looks like 3 pi over 4. So let's do that. 3 pi over 4. And then it looks like it's still been shifted down 2. Yeah, I think it's still been shifted down 2. So those are our two equations. And for this one we have to write the tangent and cotangent functions. Oh, this could be f of x is equal to tan. So first let's just write the parent function, tan of x. And it looks, normally the asymptote should be at pi over 2 and at negative pi over 2, which means that the period would be pi. But here it looks like the period is pi over 3. So that means that it's definitely been compressed some. So this could be like tan of 3x, like that. And it actually doesn't look like it's been stretched at all. Actually, let's see. Yeah, I don't believe that it's really been stretched. But it definitely has been shifted up. So we could write the +2 like that. But, and then, now if we wanted to do the cotangent function, let's just write the parent function first. And it looks like if we were to look at a cotangent function, this would be reflected across the y-axis. So first we would have to invert the sign inside of the parentheses, like that. And once we were to invert the sign, I believe we would still have to do a +2. And it would make sense that it would still, the stretches and compressions would still be the same. So I believe we would also still have to add a plus a 3 inside of the parentheses like that. Yeah, I think this seems about right. And then for the secant and cosecant functions, alright, so let us see. Okay, so let's try secant first. So a secant graph would look pretty similar to this, but it should the vertex, I guess, if you will, of this parabola right here would have to be right here. So that means it looks like it has been shifted over pi over 3 units. So this would be minus pi over 3. And then if we were to look at how it's been shifted, the distance between this point and this point, the y-coordinate distance is 4. And in a standard secant function, it would be 2. So that means that on the outside, on the outside here, you can likely write 2 secant of x minus pi over 3. And then if we were also to notice, it's also shifted down 1. So we can put a negative 1. And I believe that is it. Unless, or wait. It looks like the asymptotes are... It looks like the asymptotes are around right here. And then right here. So this looks like 2/3 of a pi. And then this is 1 pi right here, and then this 1/3 of pi. So that means this would be a distance between... This would be a period of 2 pi. Which is actually a distance of 2 pi, which is actually different from the standard function. The standard function would be 1 pi. So that means that... Which means that this should also be a 1/2, if I'm doing this correctly. So I think that's good for that. And then for the cosecant function, I think since the period and the amplitude and everything are going to be the same for the most part, I believe that this 2 would remain, and then this 1/2 would remain. But what would change would be the h and k values, because it is shifted slightly for the cosecant functions. So normally this point right here would be at 1/2 pi, or pi over 2. This is at pi over 3. So this is a shift to the left of, it appears, pi over 6. Pi over 6. So we can do a plus pi over 6 like that. And it looks like it's still shifted down 1, so that value is gonna stay the same. Alright, so that's it for the question of the day of day 7. Thanks for watching.